Hey everybody, this is Larry. This is September 15th here in, I was gonna say Leetcode land, in September here in New York City, but we're gonna do week 3 of the Leetcode Weekly Premium Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today we have 1257, smallest common region. You're given some list of regions where first region of each list contains all the other regions. Okay, so North America contains all these things. And now, naturally, if X contains X is also bigger than Y. Okay, so by definition, X contains itself. Okay, so given two regions, we turn the smallest region that contains both of them. So this is basically what you call it, least common ancestor, right? Basically, you could draw this out as a tree, and then you have a least common ancestor thing. Yeah, I mean, I think that's pretty much the idea. And there are a number of ways to do it. And for this particular problem, we don't have to we only, what I was going to say is that we only need to do this once, right? Like, we don't have to do any queries updates, so we can probably do it in a relatively, let's say, sloppy way if we, as much as we want. Relatively, maybe not too sloppy, but should be okay. Yeah, we won't have 20 things. I mean, yeah. So here we just kind of create an implicit tree, right? So maybe we can have like for region in regions. So then the first is going to be region just the region sub-0, and then so for rest, for something that's inner. What do you call it? Like for smaller, maybe, I don't know. In region, then now we want to say maybe here we have let's say children is just gonna be well, yeah, kind of that, but we actually want it to be a list, so we want a default dictionary with list. Then now children of first, we want to append smaller. I guess this is a list, so we can actually just even just say as you go to region 1, so maybe even this is fine actually, right? I mean, but you can do, I always like to write out the append in general before I realize it, because sometimes you want to do stuff to it or transform it in some way. But this one maybe it's also like you can re-index the labels if it makes any difference, but maybe for this one it doesn't that much. Maybe. And the reason why I say maybe a lot is because, well, you'll see in a sec, but the way that, like, we use it as a label, we have to just do comparison between them, and I guess the comparison is going to be more expensive. But for now, we won't prematurely optimize, so let's stick with this for now, right? So now we set up all the children in the region, and yeah, how do we know what is the I'm trying to figure out like what is the biggest region, like the root, right? And I guess the root would be the one where there are no parents. We actually don't need, I don't think we need the parents, but yeah, I think I would like a count of having parents though, right? So maybe we have has parent, it's going to be a Boolean thing, right? Or maybe just like collections that default dict of what's it called, bool, right? So then now maybe for child in region, or in, yeah, okay, fine, region, we has parent of child is equal to true, right? And the only reason why you're giving such I'm trying to see whether okay, the guarantees exist. I don't know if this is a good way of doing it. No, because the thing I'm thinking of is that I just want to get a root of the tree, but I guess technically you could have a forest, right? And sure, region 1 and region 2 could be in the same tree in the forest, but that may be, it still might mean that you have multiple roots. So maybe we just want to actually set up parent. And yeah, and then here, maybe parent is fine, assuming that. Let me double check what this. Okay, so yeah, I just want to double check that they don't give you like multiple parents, so there's no like weird setup so that there's multiple parents. I think that's what this is saying. I could be wrong. If so, then that's a little bit sad. But yeah, okay. Parent of child is equal to first, and that's pretty much it. And then now maybe we can get a get root function, and we have the current region, and we can just go up, right? So current is equal to region, while current is in parent, meaning that has a parent. Current is equal to parent of current, and then we just return current. We just basically go up the tree, right? And then now, yeah, now we can just go down the tree from the root. Root is equal to get root of region 1. They should be in the same tree, so it should be fine either way. You could take either one, but yeah. So okay, sorry. Trying to think. Okay, so then now we have the root. So then now we just have to go through the cases, right? So then now we go maybe I'll do it in a global way, but found is equal to none. So here, so what is the idea about this the smallest region that contains both of them, right? Is that traverse, let's just say this is a region, usually I call it a node, but is that there are only a few cases, right? Meaning that region 1, if there are only a couple of cases for region 1 and 2, meaning that both of them can be in one of the region, or it could be in two different, so it could be in one child, right? That means that you have to go down. It could be in two different childs. If it's in two different child, and because we're doing this recursively, then that means that this is the lowest common ancestor, right? So that's basically the idea. And of course, there are some cases where it is one of the nodes. So, for example, if region is equal to region 1 or region is equal to region 2, then region is the answer. So non-local found is equal to region, and then we just return. Otherwise, we want to see, yeah. We want to say, we know that with this as the node, with this as the root, both region 1 and region 2 is either here or in the subtrees, right? So then now we know that it is not the current node, because if it is, then that is the subtree. Then we just kind of have to find, which is that for child in what's it called, children of region, we can use a helper function, right? So yeah, if how do we want to write it? So something like if traverse of child, if this gives me if this is 2, then we go down it, right? But we maybe want to say like get region count or something, right? So if we go down this and it gives us 2, then yeah, then we want to traverse the child. keeping in mind that the thing that we're doing here right now would actually make it n squared, but we don't have to worry because we can fix that. But for now, yeah. Okay, so then else, if equal to 1, then that means, what does that mean? That means that because the other region isn't here, the other one of the region is in this child, but the other region is in another child. And we don't care about which child is in because we only care about the shared one, which means that this is the answer again. The current region is the answer. So we can say non-local found is equal to region return, right? So that's pretty much it for the traverse. So we can say traverse the root, which is the root, and then we can return found. Of course, we haven't implemented this yet. So, but that's basically the idea, right? The structure. Because if it's in one of them, then by definition, the other region will be in another child. So then now we get region count of a region, right? So, and we can implement this recursively, right, as well. So yeah, so count is equal to 0. If region is increment by 1, I guess it cannot be the same. So both of them should not be right, but I like to write it this way. Otherwise, yeah, we return count. Just kidding, we still have to do more. Which is for child in chosen region. Get region count of child. We increment by that, and that should be good. Keeping in mind though, this is n squared. Why is it n squared? Because for each region, we kick off this thing, a get region child, and get region child. So traverse, in the worst case, would be linear time. You can imagine a linked list, so it just keeps going down. But every time you go get region count, which also traverse for every child, so this makes it n squared. But let's give it a quick spin for correctness. Oh. Wait, what? No, name found is only before non-local. Maybe I have to do it here. Oops, typo. I mean, okay, yeah, I have to fix these things too. But yeah, so this looks good, but like we said, it maybe probably is too slow. I'm gonna give it a submit for the viewers at home. Maybe my future Larry will forget. Oh, huh. Apparently n squared is fast enough. And apparently I did this 5 years ago. But yeah, but I thought it would be too slow, honestly. But maybe I'm wrong, I guess. Huh. Oh, I think one input that I missed is that the region is less than 20. So I guess in that way, it will always branch out. So there won't be a n squared. I mean, it only goes to n over 20 depth, which is, I guess, fast enough. How did I do it last time? Did I do the caching thing? I don't know what I did here. It is crazy. Crazy talk. I don't know. I'm not gonna. I'm happy for past Larry for getting it right. I don't know what he did. But yeah. But so the short answer is that we can just cache this, right? Because every time we get this, if we have finger linked lists, it's going to keep going. But if we just save it down, then we don't have to worry about it. So here, maybe we have a lookup is equal to right? So then here, if region is in lookup, then we return lookup of region. Otherwise, at the very end, we do lookup of region is equal to count. Very simple. If I typed it correctly. Oh, in lookup, on lookup? Huh. The New Yorker is coming out. And yeah, it should be slightly faster for these inputs, I suppose. I don't know. But yeah, that's all I have with this one. This makes it linear time because we only call it for each region once, or at least we only do the work for it once. And here, this is just a linear traversal. So yeah, that's all I have for this one. let me know what you think. Here's the top of the code. Here's the bottom of the code. And here's me leaving the code. Thanks for watching. Stay good, stay healthy, to good mental health. Have a great weekend, everybody. I'll see y'all later and take care. Bye-bye.